So, have you seen these pictures?
Probably yes. These are the latest pictures taken by James Webb Telescope.
But do you know what these pictures reveal?
Well, for example, this image right here contains millions of stars which radiate infrared radiation. But not only this one, but that one too, and this one. But do you know one interesting thing about stars?
That's energy, a tremendous amount of energy. But how do they manage to produce that much?
Let me explain.
Nuclear fusion is a process in which two atomic nuclei come together to form a single, heavier nucleus. That process requires high temperatures and presses to merge atomic nuclei, resulting in a nucleus slightly less massive than the sum of the original nuclei. This difference in mass is then converted into energy in accordance with Einstein's equation. And if we fuse 1 gram of hydrogen, this process can release the same energy as a plasmated with 22 megatons of TNT. There are three methods to achieve fusion: gravitational fusion, which occurs naturally in stars; magnetic fusion, which is used in nuclear reactors like tokamaks; and inertial fusion, which uses lasers to compress a small sphere of deuterium and tritium.
Nuclear fusion is a very good source of energy, but I heard there's another nuclear source.
Yes, it's called nuclear fission. But before I talk more about it, we are going to explain the difference between the two nuclear reactions.
In this graphic, as you can see, the binding energy per nucleon is a fraction of the mass number. Nuclear fusion occurs with a lighter nuclei, while nuclear fission occurs with a heavier nuclei, in order to obtain a more stable nuclei, that is, containing higher binding energy per nucleon. The barrier between fusion and fission is the iron, the most stable element of periodic table.
So, the bigger the slope of the line, the better the energy performance. So, in the example, during the fusion of hydrogen, as this format shows, its energy balance is positive as the fission of uranium, but in this case less energy is released.
Okay, but how does fission work?
Let me explain.
Nuclear fission is the process of splitting an atom nucleus into two or more smaller nuclei, releasing a large amount of energy in the process. This process is typically achieved by bombarding the nucleus with neutrons, causing it to become unstable, split apart, and resulting in a chain reaction.
Now we are going to answer some questions or doubts that you might have.
Why don't we use nuclear fusion to produce energy on Earth?
It's not because we don't want to, it's because our technology and science are not advanced yet. For example, gravitational fusion is nearly impossible to do on Earth. Magnetic nuclear fusion can fuse hydrogen, but not achieve a positive energetic balance. But more recently, in Lawrence Livermore National Laboratory in California, a positive energetic balance through national nuclear fusion was achieved. But it's not good enough yet to be industrialized. Isn't it dangerous to use nuclear reactions to produce energy?
Fusion hasn't been reported with relevant risks, and fusion, it was dangerous once, but nowadays we have far more advanced safety measurements. For example, if something happens with the reactor, there are systems that are able to cool it off, and a structure that can contain the radiation, and much more, so that we can safely produce nuclear energy. What are the advantages and disadvantages of nuclear energy?
There are many advantages. If we compare with all other energy sources, nuclear energy is the one that produces the greatest amount of energy. It needs very few resources to build its infrastructures. It's a clean energy and produces little waste or even no waste at all if we talk about nuclear fusion.
Nuclear fission has a negative side. The waste it produces is radioactive garbage, however we have learned to contain and reuse it. And in fact, it's a non-renewable source, but between other energy sources needs much less fuel. And it's open to human error. But with technology, it became almost flawless.
Hi, I'm Pedro Barois,
Hi, I'm Manuel Bidaca.
and we are the team Nuclear Students from Lisbon.
We are from secondary school José Saramago.
Thanks for watching.